Hey there. So, we all use the cloud pretty much every single day, right? For streaming movies, saving our photos, for work. But if somebody put you on the spot and asked you what it actually is, could you explain it? Yeah, it kind of feels like magic, but it's not. It's actually the result of this epic, decades long journey to solve one single problem. Let's dive in and see what that is.
Okay, so let's get right to it. What is the cloud, really? I mean, for most of us, it's just this vague, fuzzy idea, right? It's this abstract place up in the sky where all our data lives. But today, we're going to pull back that curtain. We're going to look at the actual machinery that makes it all tick.
And here's the thing. The history of computing, all of it, it's not just a bunch of random inventions. It turns out it's really the story of brilliant people trying to solve the exact same problem over and over again, just on a bigger and bigger scale each time. And that one fundamental problem is something called resource sharing. It all boils down to this. How do you take one thing, whether it's a single CPU, a whole computer, or eventually an entire data center, and get it to be used by lots of different tasks or customers all at the same time without the whole system just, falling apart? This single idea, this is the engine that drove everything. So to really get this, our journey is going to follow three big evolutionary leaps. First, we'll see how we figured out how to share just a single computer. Then, we'll look at how we learned to share resources across a whole network of computers. And finally, the grand finale, sharing on the massive scale of the cloud. All right, let's jump into that first leap, making a single computer juggle. How in the world did we get one machine to do more than one thing at once? Back in the early days, computers could only do one thing at a time. Seriously, if you were typing in a word processor and wanted to open a spreadsheet, you had to literally close the first program to open the second. Can you imagine? But today, we have multitasking, where it feels like we've got dozens of apps running all at once. The key word there, though, is feels, because it's actually a very clever illusion. So who's the hero that pulls off this magic trick? It's the operating system, your Windows, your Mac OS. It became the ultimate resource manager. See, it takes the computer's brain power, the CPU time, and it slices it up into these teeny tiny millisecond-long pieces. It gives one slice to your web browser, the next to your music player, the next to your email. And it does this so incredibly fast that it fools our brains into thinking everything is running at the exact same time. Okay, so we've figured out how to make one computer juggle a bunch of tasks. Awesome. That brings us to our next big leap. Now the question becomes, how do we get a bunch of different computers to talk to each other and share things? Well, this created a brand new, massive challenge. As soon as you started connecting computers from, say, IBM and Apple and all these other companies, you immediately hit a wall. They were all built completely differently, so how could you possibly get them to understand one another? It was like a digital Tower of Babel. I mean, they were all representing the exact same information, but in totally different ways. For example, the number 10 on one machine might take up 4 bytes of memory, but on another machine, it could take up 8. They were, for all intents and purposes, speaking completely different languages. And the solution was, well, it was surprisingly human. Think about it. Around the world, people adopted English as a sort of standard language for global business and travel. Computers did the same thing. They agreed on standard formats for exchanging data. So before a computer would send information, it would first translate it into this new, standardized language. And there's a technical name for this process of translating data into a standard format. It's called serialization. You can think of it like carefully packing a box to be shipped. And then the computer on the receiving end does the reverse, which is called deserialization. It unpacks the box and puts the data back into its own native format. Okay, that brings us to the final massive leap. So at this point, we can share a single computer and we can get different computers talking to each other. We're close. But a true cloud, well, that's more than just a cluster of computers. There were 2 last major hurdles to overcome. Here were the 2 big problems. First, for the cloud to work, your application had to be able to run anywhere, on any machine in the entire data center, no matter what its specific hardware was. And second, and this is the big one, if you're going to run 2 different customers' apps on the same physical machine, you have to keep them totally separate. They need to be in their own little bubbles so one can't crash or, even worse, spy on the other. And the solution that came along and elegantly solved both of these super difficult problems was one powerful concept: virtualization. So what on earth is virtualization?
Well, the easiest way to wrap your head around it is to think of it as creating a computer inside a computer. That's literally what it is. It's a layer of software that pretends to be a completely separate, independent machine.
And this one idea solved both our problems. To fix that run anywhere issue, we got things like the Java virtual machine, which acts like a universal translator so code can run on any system. And to solve the interference problem, we got software like VMware, which creates a complete virtual bare metal computer. It basically tricks an entire operating system into thinking it has the whole machine to itself, which creates that perfect, secure isolation we needed.
Okay, so we've just rocketed through 3 massive technological leaps. It's a lot, I know. But why does any of this actually matter? What's the real-world payoff for you and me?
You know, there's this quote from the source material that just explains it perfectly. It goes like this. If a bus service is provided by a company, a driver getting sick or a bus breaking down is not visible to customers. In the eyes of customers, bus service is never interrupted. And that's it. That's the cloud in a nutshell. The massive scale of sharing all those resources makes the whole thing incredibly reliable.
And that incredible scale is what delivers on the 3 big promises of the cloud. First, you get reliability. Just like the big bus company, there's always a backup server ready to take over. Second, you get scalability. If you need more power, you just add another bus to the route instantly. And finally, it's cost-effective. Companies don't have to buy and maintain a whole fleet of their own servers. They just pay for the resources they actually use. When you step back and look at it, this entire story from the very first operating system all the way to the cloud today has been about one thing: finding better, deeper, more efficient ways to share. And that really makes you wonder, right? If the cloud is us sharing resources on a truly global scale, what could possibly be the next big leap on this journey?